to work on quadratic applications or word problems with quadratic functions. We are going to do the entirety of the lesson from the lab manual, so this is from our quadratic applications section. We're going to start with this first one. We have this function v of t here, it's given, and it tells us that v is the value of the portfolio in hundreds of dollars and t is the time in months. So when I do word problems, I like to start by really thinking through what our independent and dependent variables are and what they represent. So what is our independent variable here? Our independent variable is our input variable, so it's what's going in, right? So that's t here. And then our output variable is v of t. So what do each of these represent? Well, t, what does it say that is? It's time with the unit months. What does v of t represent? Well, it says v is the value of the portfolio. So portfolio value in hundreds of dollars. So now that we've done that, it's just nice to think about. It helps keep us straight. So how much money did Nathan initially have in his stock portfolio? Okay. All right, so now that we have that stuff, we're going to be asked a bunch of questions with a quadratic equation. This is basically just asking us real-world questions, right, in words, about different aspects of the quadratic function. We know how to find different things from the quadratic function, right? X-intercepts, y-intercepts, vertex, different values of the function. As long as we know how to do all that stuff, the trick here is to know how to translate from words to math. So let's look at this first one. So it's asking us how much money did Nathan initially have in his stock portfolio? So something that's really important here is initially. Initially means at the beginning, right? T would be 0. So how much money is in his stock portfolio when t equals 0? Well, the amount of money in the stock portfolio, or the portfolio value, is v of t, right? So if we're looking for v of t when t equals 0, that means we're looking for v of 0, right? So we just plug 0 into the function. We have 55 plus 72 times 0 minus 4 times 0 squared. Both of these terms are going to become 0, so we're just left with 55. Does that mean he has $55? No, what's the unit on our portfolio value? It's hundreds of dollars. So we have $5,500, so $5,500. When will the value of Nathan's portfolio be at a maximum? Okay, so our important word here is maximum. When we're dealing with quadratics and we hear the word maximum, what do we want to think? We want to think about our vertex. So how are we going to find the vertex of this function? Well, we use our handy formula for h. Negative b over 2a. What are b and a here? Well, we need to make sure that we pick the right coefficients. What do we notice about the form of this function? Is this in standard form? It's not quite in standard form, right? Standard form, again, we want to be decreasing with our exponents, right? So a is always the coefficient of the squared term. B is always the coefficient of the right? X or t or whatever our variable is, term, and c is always the constant. So here, b is 72. So we have negative 72 divided by 2 times negative 4. So this is 72 divided by 8, which gives us 9. So this is asking when will the value of Nathan's portfolio be at a maximum. So if we're asking for when, then that means we're looking for a t value, right? We're looking for time. Our maximum is going to be some h and some k. What do each of these values represent? Well, h is our t value. So this is when the value is maximized. And k is the portfolio value. So this is the maximum value. So if we're looking for when the value is maximized, right, when the value is maximum, then h is our whole answer. So our answer is 9. What are the units? 9 months. And what is the maximum value of Nathan's portfolio? Again, maximum value is k. How do we find k if we know h? Well, how do we find any y value of a function at a given x value? We plug in our x value, right? So we want to find v of 9, right? The value of the portfolio after 9 months. So we plug this into our function. And we can throw that in our calculator. We end up with 379. Again, is this $379? No, remember our unit here is hundreds of dollars, so this is actually going to give us a maximum value of $37,900. Awesome. Okay, next question. We've got a basketball. It's going to have this kind of quadratic trajectory, right? If you think about it, if you think about throwing something into the air, it's going to have sort of a quadratic, a parabola shape, right? So this is our function. Again, let's look at our independent and dependent variables. So looks like our independent variable is again t here, and our dependent variable is capital H of t. What does t represent? Well, it doesn't necessarily tell us. That's annoying. It should definitely tell us. Just from knowledge of physics, I'm going to say that this is seconds. It will tell you, like on WebAssign or somewhere else, what the units are. H of t, well, it says that it's given by, or no, it says that the height in feet of the ball is given by h of t. So h of t is the height, and the unit is feet. So how long will it take the ball to strike the ground? So if we think about what's going on here, right, our parabola is going to look something like that, right? So we start at this point, and it goes up and over. It's an air ball, right? And then it hits the ground here, right? In terms of math, what is this point? That's our x-intercept, right? That's where we hit the x-axis. So we need to find the x-intercept of this equation. How do we do that? Well, normally we would factor but this looks pretty difficult to factor, so maybe let's try putting it into the quadratic equation. Quadratic equation usually is x equals, but here our independent variable is t, so we have t equals negative b plus or minus the square root b squared minus 4ac over 2a. So what is b here? Again, it's our coefficient of our t term, 32. And 32 is a really big number, right? And that's going to be kind of difficult to simplify. So what can we do to make this a little bit easier for ourselves? Well, we can actually factor this. What can I factor out of each of these terms? Well, all of them are divisible by 8, right? If I pull 8 out of this, I'm left with negative 2t squared plus 4t plus 1. This is much easier to find the roots of. So now my b value, instead of being 32, is just 4. So I have negative 4 plus or minus square root of 4 squared minus 4 times a is negative 2 times c is 1 all over 2 times 1. I simplify. I have negative 4 plus or minus square root of 16 minus 4 times negative 2 times 1. Negative 4 times negative 2 is positive 8 all over 2. So I've got negative 4 plus or minus the square root of 24 divided by 2. If I throw that into my calculator, okay, so first of all, what do these represent? Well, again, our quadratic formula gives us our x-intercepts, right? It gives us our roots. So we are looking for this x-intercept here. We know that this quadratic, if we were just looking at the function itself, is going to have 2 x-intercepts. Which one is the one that we want to look at? It's the positive one, right? Okay, this should be negative 2 here. I messed up. So we actually have not 2, but negative 4 underneath here. So these are not correct. When we plug this into our calculator, we end up with negative 0.225. We also have negative 4 minus the square root of 24 divided by negative 4. We end up with 2.225. So again, we want to look at the positive x-intercept. So that is this guy. So this is the answer. What are the units here? Well, again, it's an x-intercept. I'm saying x-intercept, but really I should be saying t-intercept, right? This is our positive t-intercept. T has units of seconds, so it's 2.225 seconds. What is the domain of the given situation? Okay, so domain here, we're looking at a quadratic, which is a polynomial. Does that mean that we have a domain of all real numbers? We do typically have a domain of all real numbers for polynomials. However, we're talking about a real-world situation, right? We aren't going to really be thinking in terms of negative time. And also, right, once the ball hits the ground, it doesn't burrow into the ground for the rest of infinity, right? That would be crazy and impossible. So our domain has to stop somewhere. It's going to start at 0, right? Again, we're not going to really consider negative time. So our first t value that we want to consider is 0. And it's going to continue all the way until we hit the ground. What is the last t value? What is this t value? Well, how long will it take for the ball to strike the ground? We said it was 2.225 seconds, right? So that's my domain. What is the maximum height of the ball? So again, maximum, we want to think vertex. And again, it's asking for height, right? So height is h of t, right? It's our output value. So we need to find the output value of our vertex. Remember, our vertex is hk, so our output value is k. So we're looking for k here. We start off by finding h, so we have negative b over 2a. B here is 32. We have negative 32 divided by 2 times negative 16. Negative 32 divided by, this is going to come out to negative 32 also, is 1. What is this? Well, it's our t value of our vertex, which means it's the time in seconds where the ball is at a maximum. So in order to find k, we just have to plug that value back into the function. So h, big H, of little h is negative 16 times 1 squared plus 32 times 1 plus 18. So we have negative 16 plus 32 plus 8. This gives me 24. And what are the units here? Again, this is our y value of our vertex, so it's a height, right? It's asking for the height, and the height is in feet, so 24 feet. We are going to skip the last question here because this is inequalities. So we're done with this question. Okay, next page. All right, we've got the path of a high diver is given by a big H of D, which is here. Let's think through our variables. Here, our independent variable is D, and our dependent variable is H of D. What do each of these represent? Well, here we have D. It says it's the horizontal distance from the end of the diving board in feet. So I'm going to say horizontal, I'm going to shorten it, distance in feet. And then big H of D is, oh, this is a typo. That should say big H is the height in feet above the water. So height in feet. Okay, maximum height of the diver. Again, maximum, we want to think vertex. So HK. The height is the output value, so we're looking for K here. So we need to start out by finding H. So handy dandy formula, negative B over 2A. Negative B is 24 over 9. That's going to be divided by 2 times A is negative 4 over 9. We can plug this into our calculator, being very careful with our parentheses. We end up with 3. Very nice answer for a very ugly fraction. So 3 is our input value of our function, right? So this is our horizontal distance in feet from the diving board. So we need to plug that in to h to find k. So big H of 3 is, again, -4/9 times 3 squared plus 24/9 times 3 plus 10. We plug that into our calculator. We get -4/9 times 3 squared plus 24/9 times 3 plus 10. Gives me 14. That's K. What are our units here? Well, we said that our units of height were in feet, so this is feet. How far out from the end of the diving board is the diver when she reaches her maximum height? Okay, so again, we've got maximum, so we're thinking vertex. So we're thinking of H and K. So it's asking how far out from the end of the diving board. That's our horizontal distance, right? When she reaches her maximum height. And I know that's not super clear, but it'll be very clear what it's asking for in the problems on WebAssign. Our horizontal distance, D, again, is our input value of our vertex. So that's H. What do we need to do to find H? We've actually already found it, right? So it's 3. What are our units? Well, we said our horizontal distance is given in feet, so this is 3 feet. How far out is the diver when she touches the water? So we're diving. We've got our diving board here, and we've got our person, and the person is diving to the water. I just want to note really quickly that the way that I drew this is misleading. Remember, our D axis should start from the end of the diving board, right? D equals 0 is from the end of the diving board. So our H axis, right, our vertical axis should be right where the person is standing. Right, this is the water. So what is this point? That's our x-intercept, right? Or in this case, our d-intercept. So how do we find our d-intercept? With the quadratic formula, handy dandy. So B here is 24/9. We've got 24/9 squared minus 4 times A is -4/9 times C is 10 over 2 times A is -4/9. This is going to be difficult. So let's just actually plug all of this straight into the calculator, being extremely, extremely careful with our parentheses. All right, so it looks like we get -2.612. Let's do subtraction. We get 8.612. So which one of these is going to be our correct answer? Again, our parabola is going to kind of have this situation, right? Where we have two places where we're touching this is the d-axis this time. We don't want to pick our negative one, we want to pick the positive one. So this is our solution. What are the units? Well, again, asking how far out is the diver. The units of d are feet. So, feet. Last one. So at the beginning, so we're given m of t and t, right? T is time. But this time, what do we have going on? So t equals 0 is the beginning of 1980. So t is the amount of time after 1980. So time after 1980. Again, this is not very clear, but we're going to assume this is in years. Again, it'll be very clear for the problems that y'all have to do. Then we're given m of t, which is number of mountain bike owners. So I'm just gonna shorten that to owners. That's also gonna be our units. We'll just say owners. Okay, how many mountain bike owners were there in 1980? So 1980 is represented by t equals 0, right? So mountain bike owners would be m of t. 1980 is when t equals 0. So we're looking for m of 0. So we just plug in. I'm going to run out of space. Plus 3.96. That leaves us with, this term becomes 0, this term becomes 0, so we end up with 3.96. Our units here is not actually owners. That's my mistake. So again, m is in millions of people, right? So this is millions of owners. We don't have 3.96 owners. We have 3.96 million owners. Okay, determine the year where there was a minimum number of owners. So minimum, we want to think vertex for sure. How do we find the vertex here? Well, again, we're looking for HK. It's asking for the year between 1980 and 1990. So that's time, so we're just looking for H. So H is negative b over 2a. You'll notice this is very useful for quadratic applications. B is negative 2.27. A is 0.34. We get 3.338. Is this our answer? Do we leave it like this? Not really. It's asking us to determine the year between these years where we have the minimum number. So it's not year 3, right? It's 3 years after 1980. So what year is that? 1983. That's our answer. Okay, last question. From 1980 to 1990, what was the minimum number of owners? So minimum, again, vertex. We've got H and K. Number of mountain bike owners. That's going to be our output value, right? So we need to find K. So we have H here. So we need to plug that into M of T. Am I going to plug 1983 in here? No, right? T is the number of years after 1980, so I'm going to plug 3.338 in. So 3.338. So that's 0.34, 3.338, 2.27 times 3.338, and then plus 3.96. We plug this into our calculator and we end up with 0.171 million owners. We could also write this as 171,000 owners. Either of these are good answers. Okay, that's it. Thanks, y'all.